Hi, we are going to start Unit 4, and to be honest, this is the third time I've started this video, so I'm going to be a pro at it. Let me cover up that big dark 4 so that the video will focus better, and I can show you that we will start this on page 32. So 32 would be your 4. Page 33 is going to be where we'll do one-step equations. Now, I did something I haven't done to you all year. You know I always got to throw you a curve. I printed something for you on this yellow because I have a lot of it. The thing with this yellow is if you try to erase on it, let me try up here on this black line, it will just smear and makes a big mess. I apologize for that. If I had thought about that before we got started, I would have chosen something different. So you'll just need to know that going in about erasing. You have to be super careful. I have the steps of how to solve a one-step equation typed up at the front. But the example that I have next to you here is a two-step equation. But the setup is the same, okay? Which says draw a line down the equal sign. The reason we do that is that we're trying to separate the two sides of an equal sign. Think of it as a teeter-totter, okay? And if we have 3 kids on both sides, but one kid jumped off on one side, in order to keep the teeter-totter balanced, you would have to have a kid drop off the other side. It's kind of like the golden rule. What you do unto others as you would have them do unto you. Well, what you do on one side of the equal sign, you need to do on the other. So we like to visually separate the two sides. Then it says draw a total line. The total line is usually where you do your add and subtract step. In this two-step equation, I would leave a bigger space here because I would be doing a multiply and divide step first, and then after the total line, do my add and subtract. But with the one step, you don't need to leave quite so much space. Then step 2 says box the expression, circle, and bring down the variable. The expression is the side of your teeter-totter that has the variable. So whether I was doing a one-step or a two-step, I would still box the entire expression all the way to the equal sign that holds my variable. And then circle and bring down your variable, and then perform inverse operations. So I'm going to show you better examples with each an addition, a subtraction, a multiplication, and eventually a division problem. Therefore, whenever you practice a problem, you can say, does my problem look like this, or this, or this, or this? Okay? So here we go. Step 1, draw a line down the equal sign. Drop the equal sign. Draw a total line. Step 2, box in the expression that holds the variable, and then circle and bring down the variable. You can see that this setup allows me to have my answer that would be x is equal to, and then my solution. Looking at this box, if I've brought my x down and it's now gone, what's left in the box I need to get rid of? Well, it's a 15, and it's a positive 15. So that positive 15 means I need to do the inverse operation. Well, I should know that if I have an addition operation, its inverse is subtraction. A multiplication operation, its inverse would be division, and vice versa. These are inverse operations. So if I have a positive 15, I need to subtract 15. And positive 15 and negative 15 cancel out. So basically I would have like 0 plus x, or just x by itself. But if I subtract 15 from one side of my teeter-totter, I need to subtract 15 from the other side. And 24 minus 15. Now, yes, you can use your blue calculators, but only the blue calculators, because we will be dealing with positive and negative numbers. So I'm not going to use a calculator at all, and I'm just going to say 24 minus 15 is just like, like when I was in elementary school. It would just be a positive 9. And if you put that into the calculator, 24 minus 15, you would get 9. So my solution is x equals 9. You can always go back and check and see if that's true. Plug it back in. It said 15 plus x. If I said 15 plus 9, does that equal 24? Yes, 15 plus 9 is 24, so it's true. Let's practice now with the subtraction equation. Draw a line down the equal sign, drop my equal sign, and have a total line. Box the expression, bring down, ooh, I didn't think this through, negative m. I'm going to have to fix this for you. For a beginner, I should have put the m first. I got this, though. Now it's time to look at this. This says positive 94. So I'm going to subtract 94 from both sides. Here, already I know my answer is negative, because if I only have 13 and I'm taking away 94, I'm going to have a negative answer. And truthfully, even if you use your blue calculators and you put in 13 minus 94, it will give you an answer, and it will even tell you it's negative. So you could try that. But I'm going to come over here and say 94 minus 13, because this is a positive 13, and when my signs are different, I know I need to subtract. And that's how I get my 81. But I know that there's more negatives, so it's a negative 81. Finally, this is what I wouldn't normally teach you right in the beginning, and that is I can't have a negative variable. So I need to get rid of the negatives on both sides. And technically, I can do that by saying I'm going to multiply by -1 or divide by -1 on both sides, and then it would change the sign on both sides. I'm just going to tell you I'm changing the signs on both sides, and so my number is positive 81. Let's check it out and see if that works. 94 minus, and I said that m is 81. So 94 minus 81, is that a positive 13? Yes, it is. So m is equal to 81. Off to the side, really quick, I want to work a more typical problem. If I was to do this over again and for next year, I would have given the students a problem like, oh, m minus 13 equals 15. Draw my line, draw my total line, drop my equal sign, box, bring down my variable. If this says minus 13, I'm going to do my inverse operation of minus or subtract, and I'm going to add. So I would add 13 to both sides, and 15 plus 13 is 28. So m is equal to 28. So that's what I would do there. So now when I trim this, I'm not going to trim on this side. I'm just going to cut it really close on that side, and I should have enough space. I want you to have this better example of that when you have a subtraction problem, you would add. Let's look at our multiplication problem. Okay, now for multiplication, I'm not going to draw my total line because there's no added subtract in a multiplication if I'm just doing multiplication. The opposite of multiply, though, is divide. We actually practiced this when we did our distance formulas. If I want to get d by itself, I'm going to do the opposite of being multiplied here, and I'm going to divide with my fraction line. But what I do on one side, I have to do to the other. I'm assuming you will absolutely need your calculator to divide 111 by 37, and you will get 3. And both of these are positive, so it's just d is 3. I can plug that back in and say is 37, if d is 3 and I plugged it in, times 3 equal to 111, and you can double check yourself on a calculator. 37 times 3 absolutely is 111. So my answer was D. All right. I bet you already know what's going to happen here. You can see it's a division equation. You know what the opposite of divide is? Yes, multiplication. So here, I need to get r by itself and say r equals and have my answer. So I need to break away this -5. It's down here at the bottom. So the opposite of division is multiplication. So I'm going to multiply by -5. And it's almost like -5 over 1. But I'm just going to put -5 and make sure you put it up high next to the r. And I'll multiply by -5 on this side as well. Because what you do on one side of this equal sign, I need to do to the other. When I multiply -5 times r over -5, my negative 5's will cross out and simplify down to just one r, or r. So I got my r by itself. And 7 times -5 is -35. Let's check our work. If r is -35 and I'm dividing by -5, does that equal +7? Well, a negative divided by a negative is a positive, and 35 divided by 5 is 7. So it's true. Okay? You will have to do word problems that are two different ways. We have like a just a word problem that has 3 more than. Now that doesn't say is more than. Is more than, if I had the word is with it, would be the inequality. Like that. But this just means to add a number. I'll just put the letter N for my mystery number. Is means equals -12. Yeah, simple. So now I can draw a line down the equal sign and my total line, drop my equal sign, box everything and say, hey, there's my variable. To get rid of this +3, I'm going to subtract 3, but I'll do it on both sides. That cancels out, so N by itself, and then a -12 and a -3. Their signs are the same, so I know to add my numbers and keep the sign. Okay, so try it out. 3 plus -15 is -12. Signs are different, so I subtract and keep the sign of the bigger number. Hey, absolutely was true. Well, let's look if you have what you are used to saying, a word problem, but now we're always going to say a real life problem. If an elevator starts on the 3rd floor, so you can see where elevators are in buildings, right? So here's my building, and my elevator is going to start on the 1, 2, 3rd floor. Okay? But it ends up 3 floors, here's my ground level, it ends up down here, 3 levels below ground. So how did it move? Well, I'm going to start on the 3rd floor, okay? And I'm going to add some sort of movement. Here, I'll even put an M for movement. Add a movement to it, and it's going to end up where? At -3, because I'm 3 floors below ground, okay? So this would be my -1, -2, -3. How did I move? Well, draw down the equal sign and drop it. Here's my total line. I'm going to bring my M down for later. I still need to get rid of this 3 in the box. It's a +3. So I'll subtract 3 from both sides. Okay, that is now gone. And my -3 plus another -3, my signs are the same. So I'm going to add my numbers and keep the sign. My movement was to go down 6 floors. 1, 2, 3, 4, 5. I didn't do a very good job. 1, 2, 3. Went down 6. 1, 2, 3, 4, 5. 1, 2. Why is that not working for me? I'll have to think about that or edit that out because that's confusing. All right. Finish filling this paper, cut it out, glue it on to page 33. Thank you.